In this video, we will discuss how to work with grouped table. The challenge here, when you want to compute a metric and you have grouped information in a table, is that you don't know the exact values of the observations. So you need to make approximations. So how are you going to make those approximations? The most important element right now to make those approximations is the class mark, MI. What is the class mark? It's just the midpoint of every single class. So M1 will be the class mark of the first class. Therefore, this is an approximation because we're not using the exact values. We don't know xi. If we don't know xi, like the individual observations, then our approximation is performed by using the midpoint of each class. That's why you want to compute the x bar, then we have the sum, and I goes from 1 to k, where k is the number of classes or rows in our table. For each class, we multiply the class mark times the frequency of the class. This numerator then is divided by the total number of observations. We will keep using mi in the other metrics. For instance, here, if we want to compute variance, so instead of xi, please notice that we're using mi. And of course, we multiply the square difference using the frequency, times the frequency. Okay, so the mean value and the sample mean and the sample variance, we already found them in previous examples. But there are some more challenging metrics, and that's the case of the quantiles. The quantiles are not that simple. We need to use the following equation to compute the quantiles. Now, this equation will work regardless you're finding a quartile, a decile, or percentile. The logic is the same. So let's try to understand what are the elements in this equation. This is a interpolation, pretty much. So we have L refers to the lower boundary. Now, which lower boundary? Remember that every time that you're going to find a quantile, first step is to find the position. So once you find the position, you will be able to identify in which class of your table that position is located, looking at the cumulative frequency. So once you have found the class, then you will take that lower boundary. F, it's the frequency of that class where the position is located. A is just the amplitude, like the distance between the upper and lower boundaries. G is it's tricky at the beginning, but after a couple of examples, I'm pretty sure that it will make more sense. G refers to the number of observations that are below the position that you found inside the class. That one is tricky. I'm going to say it again, and once we're solving the problems, I'm going to emphasize it one more time. G is the number of observations below the position inside the class. So that, please don't worry right now. G, we will cover it later with an example, and I'm pretty sure that it will make sense to you. All right, so skewness and kurtosis, the equation, the structure is the same. We have cubic to the power of 4 to the power of 4. But again, since we don't know xi, then because this is grouped table, then we use the class marks, right? MIs. Okay, so now let's just implement these equations. Let's see how they work, especially the quantiles. So for that purpose, let's solve a couple of examples. In the first one, we're given a polygon plot that shows the frequencies of the serving time in minutes based on Banks-Clerk. All right, so we're given the table we're given the plot, and with the plot we will be able to find the table. How? Remember that the polygons, if we have a continuous variable like this one, time is a continuous variable in minutes, in the polygon plot you use the class mark, meaning that this 5 represents the class mark of the first class, 10 is the class mark of the second class. That's the midpoint. So if we know that the midpoint of the first class is 5 and the midpoint of the next class, the second class, is 10, then we will be able to compute the boundaries, right? The lower and upper boundaries. So we're going to split this distance in two. That means that the first interval will go from 2.5, that's the lower boundary, and the upper boundary is going to be 7.5. Then the second interval will go from 7.5 to 12.5, and we keep going until we complete all the classes. And once we know the boundaries, also you can add the frequencies. They are given here by these dots, and we know the numbers, right? The class marks are the midpoints, and they are already given 5, 10, 15, 20. So we know pretty much all the information that is required in order to be able to build the frequency table. So here we have the boundaries, the class marks, frequencies, and cumulative frequency. The cumulative frequencies are useful, especially when you are looking for a specific position in your table. All right, now let's check the questions. So the first question here is how many customers were served in the analysis? How many customers were served in the analysis? Okay, that's it. That's what I wanted to do. Okay, so how many customers? Then let's go to a table, and we know the frequencies, right? We know the frequencies. 10, 30, 25, 23, 10. So in total, 98 customers were served in the analysis. So N is going to be equal to 10. That's the frequency of the first class, plus the frequency of the second class, up to the frequency of the last one. So 98 customers were served in total in this study. Okay, the next question is, what is the average serving time? So remember that at the beginning of this unit, if you want to find an average, you use xi, like the individual observations, but we don't have them. For example, in the first class, you don't have the individual values. What you know, it's only we only know the boundaries, the lower and upper boundaries, but we don't know the exact values that are located inside that class. We know that there are 10 because the frequency is 10, but we don't know the specific values at this point. That's why, as an approximation, we use the class mark. Then let's do that. So x bar is going to be equal to the first class mark, which is the midpoint, so it's 5, times the frequency. So the frequency of the first class is 10, right? In the next class mark 10, frequency 30. And we keep going until the last one, which is 25, the class mark, and the frequency is 10. So this is 5 times 10 plus 10 times 30. And the last class is 25 times 10. The whole thing divided by 98, number of observations, right? So that will give us an approximation of the average time. This is not an exact value, it's an approximation, because we're using the class mark, right? But that's the best guess that we can make given that table. If we are provided the original data set, then of course that you will find the exact value of the sample mean. All right, so we know that on average the serving time was 14.64. Let's check the next question. What is the serving time that is greater, equal to the lowest 25% of the observations? So in part 3, we're being asked about this. These are all the observations, and we want to find a value that is greater or equal to the lowest 25%. So that's pretty much Q1, right? The first quartile. That's the question here. What is the first quartile? So if you want to compute the first quartile, remember the steps. The position of Q1. So I is equal to 1 because it's the first quartile, times number of observations plus 1, so that's 98 plus 1, 99, divided by the number of quartiles, right? 4, It's always 4. The position here is 24.75. 24.75. So how can we find position 24.75? At least let's identify in which class that position is located. So for that purpose, we will use the cumulative frequency. In the cumulative frequency, we can know which positions are located in each class. For example, in the first class, we know that we have the first 10 positions. Then, in the second class, we have from 11 position up to position 40. So there are 30 positions in total from 11 to 40. And we can keep going, right? So we need to find position 24.75. So position 24.75, it's located in the second class, right? It's not in the first one. In the first one, there are only 10 positions. Therefore, position 24.75 is in the second one because we have from 11 up to position 40. All right, so we know that the quantile, or in this case the first quartile, is located inside that class, the second one, right? And that's important because now that when we want to find Q1, when we have group data, remember that we're going to use this equation. So for this equation, we need L, which is the lower boundary of the class where the position is located. We know that. F, the frequency of that class. A is the amplitude of the class. A is the same for every single class. And G, remember that G is the tricky one. G is the number of observations below the position inside the class. Inside the class. So let's see what that means. All right, so the lower boundary, L, is 7.5, right? 7.5, that's the lower boundary in the second class. 7.5 plus, let's see the easy information. The frequency is 30 and the amplitude is the distance between lower and upper boundaries, right? So that will be 5. Then we know the F information is 30 and the amplitude multiplies this. So the only thing that we're missing here is G. So G, remember, it's the number of observations below the position inside that class. So inside the second class, there are some positions that are below the position that we found. The position that we found, remember, is 24.75, right? 24.75. That's the position that we found, 24.75. Now, how many positions are below 24.75 inside the second class? So an easy way to find that is just the position minus the cumulative frequency of the previous class. We can denote it as I minus 1. That means that the number of observations below the quantile in the second class is going to be 24.75 minus 10. Minus 10, because that's the cumulative frequency of the previous class. So what is the meaning of that? So let me write it down. This is 24.75 minus 10. So this is equal to 14.75. That 14.75 means that there are 14.75 observations below the position inside the second class. That's the mean. This is just an interpolation, guys. We're taking the minimum value, then we find a proportion here, like what is located inside the class, considering that there are 30 observations, and times the amplitude. So that's what we're getting here. It's an interpolation. So when we compute the quantile, then we know that the first quartile is equal to 9.95 minutes. So this means that 25% of the customers were served in a time lower than or equal to 9.95 minutes. 25% of them. Why 25% of them? Because we computed Q1. Okay, now let's solve part 4. So let's find D1. The logic is the same, right? if we want to get D1, then first step, the position of D1. So it's equal to 1 times 99. But here the number of splits changes because it's a decile, right? So deciles are divided by 10. So let's compute that position. That's position 9.9. So let's check where that position is located in our table. 9.9, since the cumulative of the first one is 10, then the first 10 positions are in the first class. Thus, position 9.9 is in the first class, right? Okay, so let's find now D1 using the quantile equation. Lower boundary 2.5 plus, so we need G, we need the frequency is 10, and the amplitude is the same, is 5. G is 10. I'm sorry, F is 10, that's the frequency. The amplitude is 5. And G, remember that how many observations are below the position inside the class. And we use even a mini equation over there, was position minus the previous cumulative frequency. But since this one is the first class, there is no previous cumulative frequency, right? So the equation is just the position here. So there are 9.9 observations below that decile inside the first class, because again we don't have a previous class here, so it doesn't make sense to deduct the cumulative frequency of the previous class. Alright, so when you compute the number, you get that the first decile it's 7.45 minutes, right? This is minutes. The meaning of that is that 10% of the service times are below 7 or equal to 7.45 minutes. You gotta be always, guys, aware that of the number that you are getting. If you get something bigger than the upper boundary of the class where the position is located, then there is something wrong with your equation. So, for example, if I'm using the first class here, and let's say that I get something like 9 minutes, it doesn't make sense at all because the upper boundary is 7.5. So that's something inconsistent. So you always need to check if your numbers make sense, right? So please just be careful when you are doing all the calculations. All right, so let's continue with the last one, which is the percentage of customers that require more than 18 minutes. Initially, this looks like as a harmless question. It looks easy to answer. To be honest, that's the first impression, right? What is the percentage of customers that require more than 18 minutes? So if we go to the table, so we know that, for example, in the last class, all of them, I mean these 10 guys here in the last class, those customers require more than 18 minutes. Why? Because please notice that the lower boundary here is 22.5 minutes, right? So all of them were above 18 minutes. Now, if we go to the previous one, to class 4, here is the tricky one, because 18 is located in this class, right? Located is here, 18 is here, but not all of these 23 observations will satisfy that condition, right? Not all of them. Just some of them are above 18. So now, how can we find how many were below 18 and how many observations are above 18 in that fourth class? That's the question here. How can we do that? How can we do that? How can we get how many observations are below a specific value in one class? So that's G. That's G. Remember that G was tricky at the beginning. Well, now look how helpful it's our G. So what we're gonna do here is we're gonna use the same equation, but now what I'm gonna do is, okay, if a quantile is 18 minutes and we wanna know how many are below and how many are above in one specific class, then we're gonna assume that this is the quantile that we desire. the lower boundary, because that's the equation, the lower boundary is 17.5. G is unknown, actually that's the number that we want to get, G. The frequency is 23. And the amplitude remains the same, right? It's 5 for every single class. So if we solve for G, we get that G is equal to 2.3 minutes. No, it's not minutes, I'm sorry, 2.3, this number of observations. Now, what is the mean of 2.3? Because that's what matters here. This 2.3 represents the number of observations, right, that are below the 18 minutes. So how many observations are below 18 minutes in the 4th class? So we know that there are 2.3. But remember that the question here is asking by the number of customers that require more than 18 minutes. So what we need here is the complement, right? The complement, not 2.3, because 2.3 are below. We need, it's how many are above 18 minutes in that class. So now that we want to get the total, so how many observations are above the 18 minutes, then, so let's write it down, number of observations above 18 minutes, that will be the observations that are located in the 5th class. So these 10 observations, all of them are above 18 minutes, right? That's 10. Plus the observations that are above the 18 minutes in the 4th class. For the remaining 3 other classes, 1, 2, and 3, all of the observations here are below, I mean from 1 to 3, all of the observations are below the 18 minutes. So it doesn't make sense to include them in this analysis, right? All right, so now how many observations are above 18 minutes in the 4th class? That will be the total number, 23, minus those that are below. That's 23 minus 2.3. That's the number of observations that are above the 18 minutes. So if you want to get a percentage, then you just divide this number over the total number of observations, which is 98, right? And that will give you the percentage that you were looking for. All right, so that was part 5. Part 6, it's recommended, it's an assignment. It won't be graded, it's for you to practice. It's just to find all the possible metrics that you can get using group data. That means X bar. Well, we already have X bar, so you can practice the variance, kurtosis, and skewness. All right, let's check the second and final example here. In a busy intersection, the number of traffic accidents per month were recorded. All right, we know these numbers. We're given the table. Now we're given the plot. With this plot, we can get the table easily, right? Number of accidents, that's a discrete variable. So most likely we're going to use an ungrouped frequency table, right? All right, so number of accidents, only one accident that occurred in 2 months. That's the frequency. 2 accidents in 3 months, and we keep going. So since we know the X value and the frequency, we can get easily number of accidents, the frequency, and of course the cumulative frequency. So this is not a grouped frequency table, it's an ungrouped, so it's easy to handle. It's easy to compute, you know, X bars, standard deviations, and any other metric. It's easier compared to the grouped information. All right. So now let's read the questions and let's answer them. The first one is how many months are evaluated in the analysis. How many months are evaluated in the analysis? I'm gonna add a new page here so we can work. All right, let's find n. That's the question here. So how many months? So this is simple. Please note the frequency is the number of months. So one accident that occurred in 2 months, 2 accidents in 3 months. So we just need to add the number of months, right? That will be 2 plus 3 plus 7 until the last class. The frequency is 3. So that's 30 months in total. All right, that was the first question, simple. The second one, how many accidents did occur during the study? How many accidents? So in total, so we know that one accident that occurred in two months, 2 accidents in 3 accidents in 7 months. So if we multiply number of accidents times the number of months and we add them up, that was gonna give us as a result the total number of accidents. So that's the frequency times the number of accidents, right? The value of the variable. And we're gonna sum that, right? It's the sum. So for the first month, it's 1. For number of accidents equal to 1, 2 months. For the second one, 2 accidents that occurred in 3 months. To the last one, 9 accidents that occur in 3 months. So in total, in the study, 133 accidents were recorded. All right, part 3. The question is, find the average number of accidents per month, X bar. In part 3, let's compute X bar. The good thing about X bar is that we already know all the information here. We know all the information. We know every single value of X, we know the frequencies, and we already add them up, right? So that's the numerator. So this is, I'm gonna write down the equation. So this is sum of Fi times Xi over N. And we know them, the numerator and the denominator. So this is 133 divided by 30. So we have 4.43 accidents per month. That's the sample mean, right? The average rate in the study. So let's find these two last question, number 4 and number 5. What is the percentage of months with more accidents? What is the percentage of months with more accidents? I'm sorry, with more. What is the percent? I'm missing something here. What is the percentage of months with more than 5 accidents? I was missing that last part, and that changes the meaning of this example, right? What is the percentage of months with more than 5 accidents? So that's simple. We can check that using the table. So in the first 5 classes, we have 1 accident, 2, 3, 4, up to 5, right? So in how many we have more than 5, that will be in these classes, right? Where our variable is recording 6 accidents, 7 accidents, 9 and 8 and 9. And here we have the frequencies. So we just need to add those frequencies and we can get a percentage. So that's 2 plus 2 plus 0 plus 3 divided by the total number of months, which is 30. That's going to give us the percentage of months with more than 5 accidents. So in 5, this is 4. So we have 2 plus 2 plus 0 plus 3 divided by the 30 months, right? So this is 23.3%. In 23.3% of the months, the study recorded more than 5 accidents. The last question that I'm going to answer is to compute the median, that's Q2, or the median value. So how does it work? So for 5, let's find the median. So we know the cumulative frequency. There are 30 observations in total. So that's a even number of observations, right? 30. Then when we have even number of observations, what we do is that we compute the average of the position that is located in n divided by 2 and in the position n divided by 2 plus 1. So that will be position 15 and position 16. So let's check where in this table we have positions 15 and 16. The cumulative frequency comes handy when we're doing that analysis. So in the third class, we have up to position 12. But now in the fourth class, please notice that we have from position 13, 14, 15, and 16. So we have in that class the two positions that we're looking for, 15 and 16. The easy part here is like we know that all the positions inside this class, all of them have the same value. It's 4, right? 4. Then if we find the median is 4 plus 4, 4 plus 4 divided by 2. So it's just 4. That's the median. The median. Again, the median is the average of position 15 and 16. Since this is an ungrouped frequency table, all of the observations here in this class, they are equal to 4, right? Therefore, position 15 and 16, they are the same. When the number is going to change, let's say that, imagine that the number that we're going to find the average are in positions 16 and 17. In that case, we'll need to mix these two classes, right? So it's the average between 4 and 5. But that was not the case in this example. Now, for the last one, to find the 8, first step will be to compute the position of the decile. So it's 8 times, this is n plus 1, that's 31, divided by 10. That will give you the position. Once you know that position, then you have to go to the table, check the cumulative frequency again. That information will help you to locate in which class is located that decile, the 8th decile. So let's find the position. It's 24.8. 24.8. So what I'm gonna do is I'm gonna check where it's position 24.8, and that will be here in this class. 6 accidents, right? Because the cumulative frequency is 25. That means that here we have two positions, position 24 and position 25. So 24.8, it's right there. So it's a linear interpolation, but since the value is the same, if you apply the equation, you can do it, but you will arrive to the same number because it's a linear interpolation, and the two values that you are using are going to be 6 and 6. So you will get a 6, of course, as a result. So the 8 is equal to 6 accidents. That means that 80% of the observations are below or equal to 6 accidents. All right, so that's everything for here. I'll see you in the session to practice a little bit more about how to compute these metrics when we have grouped and ungrouped